In this video, we'll go through a step-by-step process for sizing control valves for liquid flow using the ISA and IEC procedure and apply each step to an example valve. Let's go through how to verify the appropriate valve size. Step 1. Specify the variables required to size the valve. The desired valve design is a Class 300 globe valve with an assumed size of 3 inches and an equal percentage cage. We'll assume standard concentric reducers will be used to install the valve into the line. This valve has a 100% open flow coefficient, or CV, of 121 with a liquid pressure recovery factor, or F sub L, of 0.89. The process fluid is liquid propane, and the service conditions are shown. We'll keep these conditions on screen throughout for reference. Step 2. Determine the equation constants N1 and N2. From the equation constants table in the control valve handbook, N1 equals 1.0 and N2 equals 890. Step 3. Determine the piping geometry factor, or F sub P, and the liquid pressure recovery factor, or F sub LP, adjusted for the attached fittings. First, find the necessary resistance coefficients needed when the upstream and downstream pipe sizes are the same. Use the K1 equation and plug in your variables for a result of 0.37. Now use the KB1 equation and enter your variables for a result of 0.98. And use the sigma k equation and insert the variables for a result of 1.11. Next, let's calculate the piping geometry factor, or F sub P. Use the standard F sub P equation and plug in your variables for a resulting F sub P of 0.90. Then, calculate the liquid pressure recovery factor, or F sub LP. Use the equation and insert your variables to find that F sub LP equals 0.81. Step 4. Determine the pressure drop to use for sizing, or ΔPsizing. When the difference between the upstream and downstream pressure is high enough, the liquid may start to vaporize, causing choked flow. If the actual pressure drop across the valve, ΔP, is higher than the pressure drop that causes choked flow, the choked flow pressure drop, ΔP choked, must be used in place of the actual pressure drop. First, find the liquid critical pressure ratio factor. Use the F sub F equation. Plug in your variables for a result of 0.83. The choked pressure drop, ΔPsizing, is found using the standard ΔP choked equation. Enter your variables for a result of 171 psi. Since the actual pressure drop is lower than the choked pressure drop, we know that ΔPsizing equals ΔP, which equals 25 psi. Finally, for step 5, calculate the required flow coefficient, or CV. Use the standard equation for CV. Plug in the variables for a result of 125.7. The required CV of 125.7 exceeds the capacity of the assumed valve, which has a CV of 121. For this example, it may be obvious that the next larger size valve with a 4-inch nominal pipe size, or NPS4, would be the correct valve size. This may not always be true, and a repeat of the previous steps should be carried out. Now let's assume it's an NPS4 valve with a CV of 203 and an F sub L of 0.91. These values were determined from the flow coefficient table for a Class 300 NPS4 Fisher ES globe valve with an equal percentage cage. Recalculate the F sub P in step 3 using an assumed CV value of 203. First, find a new sigma k value using the equation. Plug in your variables for a new sigma k value of 0.84. Now recalculate F sub P using this new sigma k value for a new F sub P value of 0.93. Enter this value back into the CV equation from step 5 for a new CV of 121.7. This solution indicates only that the NPS4 valve is large enough to satisfy the service conditions given. There may be cases where a more accurate prediction of the CV is required. In such cases, the required CV should be redetermined using a new F sub P value based on this new CV. In this example, CV is 121.7. When we insert that into the equation, we get a new F sub P of 0.97. Now plug this F sub P value into the CV equation for a final CV of 116.6. Because this newly determined CV is very close to the CV used initially for this recalculation, 116.6 versus 121.7, the valve sizing procedure is complete. The conclusion is that an NPS4 valve opened to about 75% of total travel should be adequate for the required specifications. So that's the process for sizing a valve for liquid flow. Visit Fisher.com or contact your local Emerson sales office for more information.